Solve one problem for thick plate by using Heisler and Grobar chart. We will read the given question. A 50 mm thick iron plate is initially at 225 degrees Celsius. Its both surfaces are suddenly exposed to air at 25 degrees Celsius with convection coefficient 50 watt per meter square Kelvin. First question, calculate center temperature 2 minutes after the start of exposure. Second question, calculate the temperature at the depth of 10 mm from the surface of 2 minutes of exposure. Third question, calculate energy removed from plate per meter square during this period. Conductivity K 60 watt per meter Kelvin, density rho 7850 kg per meter cube, specific heat C 460 joule per kilogram, alpha 1.6 into 10 raised to minus 5 meter square per second.
Let us understand the given data with the help of diagram. It is given that the temperature at the center of plate is 225 degrees Celsius and thickness of plate is 50 mm. So we will draw here plate which is having thickness 50 mm, and at the center line of the plate temperature at T is equal to 0, that is initial temperature T0 is equal to 225 degrees Celsius. Now this plate is exposed to air which is having temperature 25 degrees Celsius. So we will say that temperature of surrounding TF is equal to 25 degrees Celsius. Now what is the question? Question is that we have to find out what is the temperature at the center after time T is equal to 2 minutes. So we will understand this temperature difference in between T0 and final temperature after time T is equal to 2 minutes with the help of diagram. So here we will draw one circle, and in that initial temperature T0 at time T is equal to 0 is 225 degrees Celsius, and after time T is equal to 2 minutes. So standard unit for time is second. So we will take here for time T is equal to 120 seconds. We have to find out what is the time T. Now here we will draw the surrounding temperature TF is equal to 25 degrees Celsius. Now initial temperature difference, that is T0 with surrounding temperature, that is T0 minus TF, is known as theta 0. And the final temperature after time T 120 second, T minus TF, is known as theta. Now this theta 0 is known but theta is unknown, and we have to find out this theta. If we find this theta, then we will get the temperature T. Now we will first calculate the Biot number. So for Biot number we have to first calculate the characteristic length. So what is the characteristic length for the plate? So we know that thickness divided by 2. So L is equal to thickness by 2, that is 25 mm, and standard unit is meter, 0.025 meter. Now Biot number BI HL by K. So H value, that is the convective heat transfer coefficient H, 500, L 0.025, and thermal conductivity K 60, which is equal to 0.21. Now this Biot number is greater than 0.1. So when this is 0.1 greater than 0.1, then we can say that internal temperature gradient, that is ITG, considered. And when this internal temperature gradient is considered, then we have to solve the question by graphical method. That means we will use here the Heisler and Grobar chart. Now if we observe this Heisler and Grobar chart, then we have to find out theta and theta O. So in this Heisler and Grobar chart, here theta by theta O values are given, but here is the Fourier number and here is the Biot number. So Biot number is known, that is 0.21. So we can easily find out here the values. But Fourier number that we have to calculate, and then with the help of Fourier number and Biot number we can select the value of theta by theta O. So what is this Fourier number? So Fourier number is equal to alpha T by L square. Now here T is time. Alpha is also given 1.6 into 10 raised to minus 5 meter square per second. Time, that that is 1/22 and L that is the characteristic length, that is 0.025 square. So which is equal to 3.07. Now we will find out the value of theta by theta with the help of graph.
In this Heisler chart, we have these inclined lines, that is for the 1 upon bi. And from the problem, we have 1 upon bi value is 4.76. If we observe these numbers, here is number 4 and here is number 5. So this one 4.76 line is in between this 4 and 5. While Fourier number is 3.07. So we will approximately select this line as a 3. So on this horizontal line, here is point 3. Now we will draw here one line, that is the vertical line from this number 3, and it will intersect this inclined line at 4.76. I will maximize this. So from this number 3, we will draw here one vertical line. So up to this line, we have to draw this, because 4.76, that means approximately equal to 5. Now from this point, we will again draw one line. We will draw here one horizontal line. And if we draw this line, then it is in between 0.5 and 0.6, and it is approximately nearer to 0.6. So value of this theta by theta O, that is equal to 0.58.
From graph, value is 0.58. Now we will put the value of theta and theta O, that is t minus 25 divided by 225 minus 25, which is equal to 0.58, and t is equal to 141 degrees Celsius. Now we will move to the second question. So second question is that temperature at the depth of 10 millimeter from the surface. Now if we observe the diagram, we have to first select the point which is at 10 millimeter from the surface. So for plate, this is the center line and this is the surface. So from surface, we have to take the depth of 10 millimeter. So here is the selected point, point P, and we have to find out temperature at this point P. So we will consider the initial temperature at the center is given. So initial temperature at center at time t is equal to 0 is T0, and temperature at this point P we will consider as a T. Now we have to find out this T. Now if we find the value of theta and theta O with the help of diagram, then here will be T0 225 degrees Celsius and this new temperature T that we have to find out. And here the temperature of surrounding TF is 25 degrees Celsius. So difference in between TO and TF is theta O, and difference between T and TF is theta. So here theta is unknown, that we have to find out. So with the help of graph we can easily find out this value theta by theta O. Now if we observe this Heisler chart, then there is one parameter x by L. Then there is the Bayard number. So this Bayard number is known, and here L that is the characteristic length, but value of x that is unknown. So how to find out this x? So if we observe, this x is the distance of any point from the center line of the plate. Now this is the point P. So for this point P, what is the value of x? So from the center line, we have to find out the distance of this point P. So how to find out? So we will take this half distance, that is 25 millimeter, minus 10 millimeter. Then this remaining distance will be distance x. So I will show here. So this remaining distance will be distance x. So we will calculate this x, that is 25 minus 10, which is equal to 15 millimeter, and that is equal to 0.015 meter. So x by L is equal to 0.015 divided by 0.025 is equal to 0.6. Now from the Heisler chart, this x by L value is known, this bar number is also known, then we can easily find out this value of theta by theta O.
From this chart, we have value of x by L that is equal to 0.6 and 1 upon Bi that is 4.76. Now we will select the point for 1 upon Bi 4.76. That means it is approximately equal to 5. So we will draw here one vertical line from this point. That is, here is point 1 and here is point 10. That is, in between this 1 and 10, we have to select one middle point. For the point 76, we will approximately select as a number 5 and we will draw here one vertical line. Now we have here 0.6, that is x by L value is 0.6. So we will draw here vertical line and here is the point of intersection for this 0.6. Now from this point of intersection, we have to draw here one horizontal line. So again, I will select one line and here is the point of intersection. So what is the value of theta by theta O? So it is in between 0.9 and 1. So value of theta by theta O, that is 0.95.
From graph, theta by theta O is equal to 0.95. Therefore, t minus 25 divided by 225 minus 25 is equal to 0.95, and therefore t is equal to 135.2 degrees Celsius. Now we will move to the third question. So third question is energy removed from plate per meter square. So it is mentioned that this energy removed, that is nothing but the internal energy for this plate. So we have formula for the internal energy mCp delta T. Now if we observe this question, here the mass of this plate is not given. So instead of m, that is mass is equal to density multiplied by volume. So we will use here density multiplied by volume. Cp is the specific heat and delta T, that is the temperature difference in between this plate and the surrounding. Now if we observe the given question, at time T is equal to 0, temperature T0 is given, that is 225 degrees Celsius. And here temperature Tf is 25 degrees Celsius. So we can easily find out this T0 minus Tf. So this initial internal energy, so we will show here this initial internal energy with letter Q0. So this initial internal energy is Q0, that we can easily calculate. So rho density is 7850, volume, that is area multiplied by thickness. So what is the area? So question is that energy removed from plate per meter square, that is per unit area. So here we have to take 1 unit area, that is 1, and thickness is 50 millimeter, that is 0.05 meter. Then Cp 460 and To minus Tf, that is 225 minus 25, that is 200. So when we calculate this, we will get the value of Q0 is, because this is the value for time T is equal to 0. We have used here the temperature T0. So Q0 is 35.33 into 10 raised to 6 joule per kilogram. Now if we observe the Heisler chart for plate, then here from the graph the value of Bi, then Bi square into Fo, that is Bi square into Fourier number, and Q by Q0 is given. So we have to first calculate Bi square into Fo. So Bi is equal to 0.21 and Bi square into Fo, that is 0.21 square into 3.07, which is equal to 135. So now these two numbers are known, that is Bi and Bi square Fo. So from these two numbers, with the help of graph, we can find out the value of Q by Q0.
From this chart, we have Bi value 0.21. So if we observe here number, here is 0.1 and here is 0.2. And Bi square multiplied by Fourier number. So we have calculated 0.135. If we observe, here is number 1 and previous number is 10 raised to minus 1. So 10 raised to minus 1, that is 0.1. So we have to select here slightly greater number because value is 0.135. So I will select here this point, and from this point we will draw vertical line. So here is the point of intersection, and from this point of intersection we will again draw one horizontal line. So what is the value for Q by QO? That is, it is in between 0.4 and 0.5. That is, this value is 0.45.
Now from graph, the value of Q by Q0, 0.45. Therefore, this Q0 is known. So Q is equal to 0.45 into 35.33 into 10 raised to 6 joule per meter square. And now we will convert this into kilojoule. Then 15.9 into 10 raised to 3 kilojoule per meter square.